Welcome to Classes with Atish. In today's lecture, we will go over mechanics. We'll talk about kinematics, and we will also take a special case where we will study kinematics in a constant acceleration case. Okay. Let's start with introducing a few concepts. First concept I want to talk about is distance and displacement. When a body moves from a point A to point B, let's say this is point A and this is point B, it can move in whatever fashion it wants. Let's say it covers a path like this. The length of this path is the distance that the body covered from A to B. However, the displacement is a vector which joins point A to B. So basically it is the shortest distance between A and B, and the direction of the vector points from A to B. Okay, very basic concepts. Now let's understand this using an example. Let us say we have a circle. And let's say this is the x-axis, this is the y-axis. And let's say a body moves from this point, let's call that point A, along the arc of the circle to point B. The radius of the circle is r. Okay. Question is, what is the distance that the body covered and what is its displacement? If you want, you can pause the video and find it out and then unpause to see what is the final answer. So like we know, the distance is the length of the arc or length of the path that the body covered. Since we know this is 90 degrees and we know the perimeter of a full circle is 2 pi r. However, we are only covering 1/4 of the perimeter, so the distance covered will be divided by 4, which is pi r by 2. Okay. How about the displacement? The displacement is the shortest distance from A to B. So if we join a line from A to B, then the length of this line would be the displacement. So let's calculate the displacement now. So we know this is a right angle triangle with two sides r. So using Pythagoras theorem, it's very easy to compute. So it will be square root of 2r square, or we can also write r root 2. Okay. Now let's take another example using the same circle. Let's say a body moves from point A to point B. It's not necessarily 1/4 of a circle, but then it moves such that the angle between these 2 points is theta. In this case, can you find out what is the distance and the displacement? Again, if you want to pause the video and compute, go ahead and do that, but I will come back and tell you the answer. Okay. Now distance in this case, so this is case number 1, we already talked about that. In this case, the distance is very easy. If theta is represented in radians, then you would know that the length of the arc AB is r theta, where theta is measured in radians. Okay. However, the displacement, this is a little tricky, is the shortest distance between A and B, which is the straight line. Okay. Now this is no more a right angle triangle, so it's a little difficult to compute unless you know a little bit of trigonometry. But it's good to remember this. The displacement will be 2r sine theta by 2. Okay. All right. Let's move on to the next concept. The next concept is about average speed and average velocity. Average speed is defined as the total distance covered by elapsed time to cover the distance. Whereas average velocity is the total displacement by elapsed time. Okay, it's always good to remember that displacement will always be less than equal to the distance, right? So in the same way, velocity will always be less than equal to speed. Okay, let's solve one question. If a body covers n equal distances with velocities v1, v2 up to vn, then find out the average speed. So what that means is a body covers n equal distances, so this one with velocity v1, this one with velocity v2, v3 goes on like that with velocity vn. What will be the average speed? Okay, it's easy if you remember this formula. So what is the total distance that the body is covering? So if each length is d, right, then the total distance that the body is covering is n times d. And what's the total elapsed time? The total time, we know speed or the modulus of velocity is distance by time, right? So time is distance by speed. So distance d is covered with v1 speed. The next distance d is covered with v2 speed. So if you go on like this, d by vn. Okay. So what is the average speed? The average speed will be n times d divided by d by v1 plus d by v2 all the way to d by vn. We can cancel out d's, so this will be n by 1 by v1 plus 1 by v2 1 by vn. Next we will talk about instantaneous velocity. So to explain instantaneous velocity, let's first draw a displacement time graph. Okay. So displacement in the y-axis, time in the x-axis, this is displacement. Okay. Let's assume displacement is a function of time like this, at square. So this will be something like this. Okay. Now instantaneous velocity v is defined as the rate of change of displacement. So if we take a tangent at any point on this graph, let's say at this point, take a tangent, then the angle here that it makes is theta. So ds dt is nothing but the slope of the st curve, which is nothing but tan theta. Okay. Now if we bring dt on the other side, so ds becomes v dt. Now let us do a definite integral s1 s2 for ds and over t1 t2 over v dt. Let's draw a velocity time graph. Velocity in the y-axis, time. Now let's say this is this. Okay. Now what is the definite integral v dt from t1 to t2? It's nothing but the area under the graph. So this area where this starting is t1 and this is t2. Okay. So the change in displacement s2 minus s1 is integral t1 to t2 v dt, which is area under the vt curve. Okay, so if we have to, based on this, if we have to find out what's the velocity, so v is ds dt or d dt of at square. If we do the derivative, it is 2at. So this graph is actually v equals 2at. This should actually pass through the origin in that case. Now similarly, if we do v dt integral t1 to t2, so that will give you the change in displacement. Let's denote that as delta s. So this will be integral of 2at dt is 2a t square by 2. 2 gets cancelled out, and this is from t1 to t2. So this is a t2 square minus t1 square. Moving on to the next concept, we'll talk about instantaneous acceleration. So let's draw the velocity time graph one more time. Okay. Now instantaneous acceleration is the slope of the velocity time graph. So if you take a tangent anywhere, let's say at this point, the slope of the curve at that point, tan theta, is the acceleration at that point of the velocity time graph. Okay. Now if we draw acceleration time graph, okay, then let's do this. dv is equals to acceleration times dt. Okay, if we take an integral of v1 to v2 dv and integral t1 to t2 a dt, so we know the integral of a acceleration time graph is again the area under the graph. T1, T2. Okay. So the change in velocity v2 minus v1 is nothing but T1, T2 integral from T1 to T2 acceleration times t. Okay. So change in velocity is equal to the area of the acceleration time graph. So these are the basic formulae that we need to remember. Now these definitions apply for all situations. Now we'll take a special case when acceleration is constant. There are three equations of kinematics that we will just list down. It's important to remember those three equations. These are the equations of motion for uniform acceleration case. It's very important to remember that this only applies for uniform acceleration. If acceleration is changing with time, then these equations will not apply. So be careful not to use them in those scenarios. The first one, v equals u plus at, where u is initial velocity, v is final velocity, a is constant acceleration, and t is elapsed time. Okay. The second equation is s equals ut plus half at square. S is the displacement. Okay. And the last equation, v square is equal to u square plus 2as. Okay. So it's important to remember these three equations of motion. But like I mentioned, always remember that these only apply for uniform acceleration case. Okay, so these are the very basics of kinematics. I will throw in a question for you to solve. It will come up right here. Take your time to solve this, and in the next video I will give you the solution for this one. Okay.